Hello and welcome to another video lesson with Mr. Roman. Today we're going to be talking about similar figures. And when we say the word similar, what we really mean is proportional. So similar means proportional. And the first example I'd like to look at is a rectangle where we have two rectangles that are really identical shapes, but they're just one's bigger than the other. And so what we call this is a proportional figure or similar figure. So I can make this rectangle as big or as small as I want it to be based on the sides or the scale factor of this figure. So in this example, we're given that we have 8 and 4 of the sides of this rectangle, and we have x and y the other sides. And if we wanted to increase the smaller rectangle by a factor of 3, we would simply take 8 times 3, which is 24. So y here would be 24. And then we'd say 4 times 3, which is 12, and x then would be 12. So the two rectangles then would be similar figures, and the ratio of their side lengths would be proportional. So for example, we could say the ratio of the length to the width of this rectangle, 8 to 4, in its simplest terms would be a ratio of 2 to 1. 2 to 1 ratio. And that's the same ratio as the length and the width of the bigger rectangle here, which was 24 and 12, which reduces then to simplest forms as 2 is the length. 2 is the length, and then 1 as the width. So they are proportional. And 3 would be called a scale factor. That's a special word that we're going to talk about, is the scale factor. Okay. In example 2, you're told that a basket manufacturer has headquarters in its office building that has the same shape as the basket they sell in stores. So the following picture is a picture of that headquarters, that office building, where they have that in Ohio. So basically what this headquarters did was they took the basket that they sell in stores and they made a proportion out of it, and they said, hey, we want to make a scale model and make the real life thing for our building. So the actual basket itself is has a ratio of 15 inches to 10 inches for the length and the width, and the building itself has a length of 192 feet and a width of, we don't know, we're trying to find that. So here we can set up a proportion to say that these two things are equal. However, when we're dealing here with inches and feet, we want to look to maybe convert those units. You can either convert feet to inches or inches to feet. In this case, I'm going to convert the inches to feet. So 15 into feet would be 1.25 feet. And the 10 divided by 12, which would be 0.83 repeating feet. Okay? And that's a good habit to get into, is make sure you're dealing with the same types of units. And then here we would want to use what we call the cross product, which we can take as 1.25 times x equals 0.83 times 192. So that when we solve for x in this equation, we're going to get a decimal, which is an approximation. It's 127.488, which is about 128 feet. So we can say the width of this building that looks like a basket, and it's proportional to the original basket sold in stores, is 128 feet. In example 3, we're told that we have an isosceles triangle, and the legs of the triangle are 12 inches, or 12 centimeters, and the base of the triangle is 8 centimeters. And then we're talking about another triangle that's similar to that with legs that are 78 centimeters. We want to find what the base of that other triangle would be. So here we can set up a proportion of 12 to 8. So we have the leg of the triangle to the base of the triangle. That ratio is 12 to 8. And then the leg of the new triangle, which is 78, to the base of the new triangle. Now we can solve that proportion using, again, the cross product here. So we'd have 12x equals 8 times 78. And then when we solve for x, we'll get to that the length of that base is going to be 52 centimeters. We can also use what we call the scale factor here, and we could say, okay, what number times 12 gave me 78 centimeters? And that number would be 6.5. So here, 6.5 would be called the scale factor. And I forgot to talk about this in the second problem, but the second problem, the scale factor you could say was what number times 1.25 would equal 192? And we would say here that the scale factor then was 153.6. So let's go ahead and write that down. So the scale factor in this case was 153.6. And that comes from taking 192 here divided by 1.25. In example 4, we're told that we have a road map and that the scale of the road map here at the bottom is every 6 inches we can travel 5 miles on the map. And so we call that really like the scale of the map. And so here when we set up a proportion to find out how long it would be, how many miles it would actually be if we had 2.5 feet on the map, well, we need to convert that either the feet to inches or the inches to feet. And I went ahead and did the 2.5 feet. I went and turned that into inches here. So that's 30 inches. And then so the proportion that I'm going to use is this one right here to solve for the number of miles. And again, you can either use the cross product or you can use the scale factor. If you use the cross product, you're going to get this, 5 times 30. And then 6x equals 150. And then you'll find that x equals 25 miles. If you use the scale factor method, you're going to say, what number times 6 gives me 30? And you'll find out that the scale factor here is, in fact, 5. So 2 ways you can get the same thing and to give you the 25 miles. So using that scale factor, you would say 5 times 5, so the scale factor of 5 times the 5 miles would give you the 25 miles there. In example 5, we are told that we're on the Smoky Mountains National Park map and that we have 3 inches is 10 miles on this map. And so here, again, we can set up our proportion with the fact that we want to know how many miles 1 1/8 inches on the map. And we know it has to be less than 10 miles because we're dealing with less than 3 inches. So again, we can use the cross product or the scale factor method. If you use the cross product method, you're going to get 3x equals 10 times 1.8, or 1 1/8, I'm sorry, and then you'll get x is 3.75 miles. If you use the scale factor method, you would basically say what number times 1 1/8 would equal 3. So in this case, you would say that the scale factor would be 8 over 3, or as a mixed number, 2 1/3. You could also use the scale factor going the opposite way. If you wanted to go from the 3 to the 1 1/8, then the scale factor would then change to 3/8. And again, that's all depending on how you're going to do the problem. But depending on which one you go, if you go from the 3 to 1 1/8, then you're going to use 10 times 3/8 to do this. If you use the 2 1/3, you're going to go x times 2 1/3 would give me 10. So it all depends on what direction you're wanting to go with the scale factor. In example number 6, we're asked to find the length and width of a rectangle, and the perimeter of this rectangle is 50 inches. And we need to know the formula for the perimeter of a rectangle, which is P equals 2L plus 2W. And then we can substitute in for P, which is 50 inches. We also know that the ratio of the length to the width is 3 to 2 here. And that's a crucial piece of information because we don't know what the length and width are, but we do know that their ratio is 3 to 2. So what we can use then is proportionality to say some ratio of the 3 and 2 will get us to a length and width that will give us the correct values. So eventually we're going to get there. We can use the guess and check method on this one, but we want to build a concept here. And whatever that scale factor is that we're going to multiply the 3 by and the 2 by, that's what we're going to use in the equation. So 3 times x would be x representing our scale factor. So let's go ahead and write that, scale factor. So 3 times some number x, which is the scale factor, is going to give us the length that we're going to want for the new rectangle, for the rectangle. And then 2 times that same number x, the scale factor, is going to give us 10, or the new number for our rectangle. So what we're going to use in our equation, instead of L and W, we're going to replace L and W with what we know their proportion is in the problem. So here we can say 50 equals 2 times 3x, because that's the length ratio, plus 2 times 2x, because that's the width ratio. And then we're going to solve the equation for x. So we have 6x plus 4x, 50 equals 10x, and then x equals 5 here. So the scale factor in this case is going to be equal to 5. So then what we can do with that scale factor is we can say, hey, you know, we're going to multiply the length ratio here by 5. So we're going to multiply by 5 to give us 15 inches. And then we're going to multiply the width by that same scale factor of 5, and we're going to get 10 inches for the length and the width. So the length is going to be 15 inches. The width is going to be 10 inches of this new rectangle. Then on example number 7, we were told that we have the ratio of the length to the width here. The length to width was 5 to 2. So the 5 representing the length here, so 5 times the scale factor was x, and then 2 times the scale factor here. And when we go to solve this equation, we're going to go ahead and go through this process, which we're going to find that x, the scale factor, is 37.5. And then the way to find out what the length and width are is you basically take each of those numbers and you multiply by 37.5. So 5 times 37.5 is going to equal 187.5 for the length. And then 2 times 37.5 is going to be 75 for the width. Then the next example we're going to look at is dealing with an actual triangle here and similar and proportional sides of the triangle. So we're told that AB is has a ratio of, or AB and AC have a ratio of 3 to 5. So we can write the following proportion here, and really this is the one that we're going to be using to solve for x in this case. And you can use the cross product method, which I show here. So 3 times 25 equals 5 times x, and you get x equals 15. Or you can use the scale factor method. The scale factor method would say 5 times what number gave me 25, so scale factor in this case would be 5. And then you take 3 times 5, which is going to be 15. It's important to note here, though, that sometimes the variable that you find doesn't always necessarily equal the side length. So here in this case, AB, the side length, does actually equal 15, but that's not always the case. Then in the next example, we're given a triangle where we're told that the ratio of AB to AC is a ratio of 7 to 8. So we're going to use that information to set up the proportion here of the two sides. And then we can use, again, the cross product, which is what I show here. 7 times 48 equals 8 times 14x. And then, forgot my x there. And then you're going to solve for x, and x is equal to 3. But here, x is not the length of the side AB. To find the side AB, you would put in 3 for x and take 3 times 14, which is in fact 42. Okay? Now, if you were using the scale factor method to solve this proportion, you would say 8 times some number will give me 48. So the scale factor here would be 6. And then you take 7 times 6, which would equal 42 here at the top. And then take 42 divided by 14, which would give you x is 3. And the last example that we're given, we have the ratio of A to B, or AB has a ratio to AC of 15 to 8. So we're going to set up the proportion here that you see in red. And to solve the proportion, you would say cross product would land you with the distributive property here. And you get 45y plus 30 equals 480. And then solving for y, you get y equals 10. But again, 10 is not the value of the side AC. You'd have to plug in 10 for y here, and then say that AC, the segment length AC, is 32. Now, if you use the scale factor method, you would say that 15 times some number will give me 60. And in that case, you're going to say scale factor is equal to 4. And then take 8 times 4 would be equal to 32. So then 32 would equal to 3y plus 2. And you could solve for y by subtracting 2 from both sides. That's going to equal 30 equals 3y. And then again, y is going to equal to 10 here. So either way, when you use the scale factor or the cross product, you're going to come up with the right answer.